In creating the radial engine assembly, sub-assemblies become necessary to reduce the workload of constraining many components. The first sub-assembly that will be used is the piston assembly, which consists of the piston, piston rings, piston pin, and the piston pin plugs. We'll start off by entering into assembly design, and we'll import our existing components which were created earlier, and one by one we'll import each component. And if we need multiples of one component, we can just copy and paste them once they are imported. When importing components, they are often occupying the same space. It's easier to just move them over so you can get to the constraints you will need. Once the rings are imported, we will then use the manipulate toolbar to separate them. And we'll begin by constraining the piston rings. There will be two constraints for each ring. One is a coincidence constraint. The second is a contact constraint with the piston. Once these constraints have been placed, we can update the assembly and make sure our constraints were correct. We will need two piston pin plugs for this assembly, so we'll need to copy paste another plug. But first, we'll constrain the piston pin. The piston pin will also only need two constraints: an offset constraint and a coincidence constraint. The piston pin plugs will also need a coincidence constraint along with a contact constraint. Once our part is updated, there is one more important step to making sure it is correct. We will need to test the constraints. We'll do this by using the explode command. We will fix the piston head and explode the rest of the parts out. And then we'll use the manipulate toolbar or tool to twist and turn the other components into strange orientations to truly test our constraints. If once we update our assembly after we have fixed our components in new orientations and it comes out correct, our constraints are valid and we are not under constrained. The articulated rod assembly will be connecting the piston assemblies to the master rod. We'll once again enter into assembly design, starting over. We'll rename our assembly and we'll import our already existing components, the articulated rod, the upper and lower rod bush, and our piston assembly will be incorporated into the articulated rod assembly. Incorporating the piston assembly here into our articulated rod assembly simplifies the process once we incorporate our rod assembly into the radial engine assembly. We'll be dealing with a lot less constraints because we'll be copying and pasting assemblies instead of creating individual separate assemblies. Many of these parts only need two constraints, a coincidence and an offset constraint. When creating an offset constraint, it is important that a surface be chosen, not just a line. Otherwise, there are too many options for the part to still meet that constraint, but be in the wrong position. As you can see, it is also important to be careful, as negative and positive offset constraints can easily be mixed up. You must always check your part. It is obvious that this part also needs one more constraint now, an angular constraint, which is the first time we'll have used an angular constraint. Once this assembly is properly constrained, it would be good to also test this as we did the piston assembly by exploding and manipulating and updating to make sure it works. The radial engine assembly is next. This is what we have been working towards, and we'll be incorporating our piston assembly and also our articulated rod assembly along with a link and of course the master rod and the master rod bearing. While the articulated rod assembly has a piston assemblies incorporated, we still need one separate piston assembly that directly connects to the master rod. And that will be the first part that we constrain. It will need three constraints. It will need a coincidence, an offset or an offset constraint, and one angular constraint. It is also wise to fix the master rod to make sure that the master rod always stays in one place and is not being constrained to other parts, but those parts are being constrained to it. Now that the piston assembly is assembled, we're constrained to the master rod. After constraining the master rod bearing, we will constrain the articulated rod assemblies, and they'll have angular constraints that will reference the piston assembly's axis, as well as contact and coincidence constraints. And of course we're going to need 4 articulated rod assemblies, so we'll copy paste and also 4 link pins. Separate the parts so we have easy access. It is always good to constrain parts completely, part by part, and not random constraints jumping from one part to the next and back to the other. So we'll fully constrain one part and then we'll move on to the next. A little coincidence, and then it's actually a contact constraint. And then we'll follow that up with our angular constraint to the piston head axis. And now we can move on to the next articulated rod. And we'll do the links last. It is always smart to continually update your part to make sure the constraints you're entering are the ones you really want. Now we can see that our articulated assemblies are in the correct position. Since the link pins only need 2 constraints each, a coincidence and a contact constraint, it's okay to go ahead and constrain them all at once, as long as you remember which one goes into which hole, so that you don't constrain 2 to the same position. And the contact constraint anywhere on the surface is okay. Zooming in on the piece, we see that everything is in the correct position. And once again, it would be a good idea to test your constraints by exploding the piece, manipulating the parts, and updating to make sure they update to the right positions. This is very important in testing your part and is often overlooked. Luckily for us, it works.